Welcome to the Geiger YouTube channel. Maharashtra SET 2021 question with detailed explanatory answer. Paper 2 Chemical Science Part 6. Question number 69. When 10 ml of 0.1 m NaOH and added to 10 ml of 0.1 m HCl, pH of the solution will be. The number of moles is equal to molarity of the solution divided by volume. Here for NaOH it is 0.1 divided by 10 ml. For HCl, number of moles equal to is also 0.1 divided by 10 ml. For HCl also the number of moles equal to 0.01. Hence, the number of moles of NaOH is equal to the number of moles of HCl. Both are equal, which reacts to give NaCl plus H2O. Hence, the pH will be neutral, that is equal to 7. The pH will be neutral. The pH will not be acidic or the pH will not be basic. Hence, option B is correct. Question number 70. Activation energy has been given and enthalpy of the reaction has been given. For the following gas phase, CO carbon monoxide plus NO2 gives CO2 plus NO2. Activation energy you have to calculate EA of the reaction. CO2 plus NO2 gives CO plus NO2. That is, listen here, this reaction has been just reversed here. The product becomes reactant and the reactant becomes a product. So what will be the value, activation energy EA value they are asking. For carbon monoxide, this gives carbon dioxide. Here the EA has been given. EA equal to 134. Delta H has been given, which is minus 234. This reaction is a exothermic reaction. This is an exothermic reaction. Delta H has been given. For the reverse reaction, we just see for the reverse reaction, the EA will be same, 134, and delta H will be equal to plus 234. Delta H will be plus 234, not minus 234. Hence, EA value, EA equal to 234 plus 134, which is equal to 368 kilojoule per mole. This will be the answer. You see here, option C is the correct answer. Option A will be the correct answer if delta H will be given is 234. If it is an endothermic reaction, you will get the answer EA equal to 100 kilojoule per mole. But they have given delta H equal to minus 234. Hence, you have to add 134 plus 234, which is equal to 368 kilojoule per mole. Question number 71. The rate of the catalyzed reaction, enzyme catalyzed reaction, the Michael-Menton's equation has been given. It's a Vmax into S Km plus S. So, which of the following is correct about the unit? Let us take here the Km is nothing but a concentration term. It's a concentration term which is equal to mole per dm cube. It's nothing but a concentration. Hence, this Michael-Menton's constant is a concentration term Hence option B is the correct answer. When Km equal to S, Vmax, V equal to Vmax, this option is wrong, because in this equation, listen, if you substitute Km into as S means you will get Vmax into S. When you substitute this Km into S means you will get S plus S, Vmax into S divided by 2S. This S cancel, and V will be equal to Vmax by 2. Vmax by 2. But here they have given V equal to Vmax. If V equal to Vmax by 2 means this option will be correct. Hence this option is wrong. At low substrate concentration, V varies exponential with no, it varies with linearly with S. Hence this option is also wrong. In option A, the unit dm cube per mole, this unit was reversed. Hence this option A is also wrong. Hence option B is the correct answer. Question number 72. Compound contains two types of atom, X and Y. It crystallizes in cubic lattice. Atom X at a corner and of the unit cell and Y at the body centered. The simplest possible formula of this compound is, it's a body centered cube where let us take the compound X at a corner. So there are 8 corners. For one atom, 1 into 1 by 8 into 8, which is equal to 1 atom. Let us take compound Y, which is a body centered. This is a body centered cubic lattice. Hence Y at a body center. For body center, for one cubic lattice, there will be 1 atom. So let us this cube. At the body centered, there will be 1 atom for 1 cube. This is a body centered cubic lattice. So 1 into 1, which is equal to 1 atom. Hence option X equal to 1 and Y equal to 1. Hence the simplest formula is X into Y. Hence option C is the correct answer. Question number 73. How many initiator fragments are present in a polymer chain formed by coupling termination in addition polymerization? In addition polymerization, there are 3 steps: initiation, propagation, and the final step is the termination. So for termination, a product to terminate, for example, if you add 2 radical, you will get R2. The reaction will be terminated. The reaction stops. Likewise, in addition polymerization, so minimum 2 radicals is required for termination. Hence option B is the correct answer. Question number 74. Based on tacticity, the polymer is divided into dash types. There are 3 types of tacticity. One is a syndiotactic. Second one is isotactic. Third one is atactic. Tactic means the arrangement of groups or atoms. Option C is the correct answer. A step reaction polymerization proceeds by condensation polymerization. The stepwise reaction does not follow in addition polymer, anionic or cationic. It is a condensation polymerization. Question number 76. The polydispersity ratio, that is index of a polymer, that is a PDI, polymer dispersity index, is given as weight average molecular weight divided by number average molecular weight. In this option, C is the correct answer. Question number 77, the diagram is given below for a silicon crystal at 300 Kelvin. From the diagram, it is inferred that Fermi level is 0.38 electron volt below the intrinsic level of EI. Semiconductor is P-type, semiconductor is N-type. EC minus EV is 0.56 electron volt. Which one is the correct answer? Here, EV is the valence band, EC is the conduction band, EF is the Fermi level, and EI is the difference between that level. For Fermi level, for pure solid, EI is equal to EV plus EC divided by 2 for a pure semiconductor. For example, if the semiconductor is P-type, we have conduction band here EC and valence band here EV, and EF will be here and EI will be here, and there will be a band in between this one. This is EA, acceptor band. Suppose if it is an N-type semiconductor, you will have the conduction band here and the valence band here. EF will be above the acceptor band, sorry, donor band. This ED is a donor band, and this EI. Hence, EF will be above, and here the EF will be below. Let us take the question. From the question, now you can understand the Fermi level is 0.38 below the intrinsic semiconductor, that is A, option A is correct. The semiconductor is P-type material, option B is also correct. Here the question is wrong because option A and option B both were correct. N-type semiconductor, it is above the, option C was wrong. In option D, EC minus EV is equal to 0.56 into 2. Hence option D is also wrong. Both option A and B are correct. Question number 78, at 445 Kc for the following equilibrium reaction. The mixture H2, I2 and HI are present in a closed vessel. HI is given, H2 and I2 is given. Here Kc equal to the concentration of the product divided by the concentration of the reactant, which is equal to the concentration of the product is I2 into H2 and the concentration of the reactant is HI whole square. Kc equal to, which is equal to 0.005 divided by 4. In this question, actually this question was a wrong question. No answer matches with this, but here QC will be equal to Kc because it is an equilibrium reaction. The answer given in this question, the value, I think the value is wrong. because if you substitute this value, the Kc will become should be equal to Qc. So hence the opt answer is Qc should be equal to Kc. The system is in equilibrium. These are all correct, but this is because of this. This is an equilibrium reaction. Option A is the correct answer, I think. In a canonical ensemble, a system X of fixed volume is in contact with a large reservoir Y. Then X can exchange only energy. Exchange only particle. Can exchange neither energy nor particle. Both energy and particle. Which is the correct option? Listen, for a fixed canonical ensemble, mu, that is the particle, is fixed. Volume is fixed. Temperature is fixed. Hence, the energy only exchanges, not the particle. Particle is not exchange. Here the particle, this was also wrong. This was also wrong. Hence option A is the correct answer. Energy is only exchange. According to Fermi-Dirac statistics, the following assumption is made. Here in Fermi-Dirac statistics, the particles are indistinguishable. But only one particle may occupy the given energy level, and that one particle is nothing but a fermion. That is an electron which is called as a fermion that occupies the energy level and which is an indistinguishable particle. You have to remember. In option hence here it's a distinguishable, it's a wrong. Option A and D is ruled out. In option B, it's also indistinguishable is correct, and but any number of particle is wrong, because only one particle which is an fermion reaches the given energy level. Option B is wrong. Option C is the correct answer. Question number 81. The ratio of energy of an electron in ground state of hydrogen atom to that of electron in first excited state of beryllium B3 plus is. Here the energy is given as En is directly proportional to Z square, that's atomic number divided by N square. For hydrogen atom, He equal to 1 square divided by 1 square, which is equal to 1. For beryllium, B3 plus EB3 plus is directly proportional to the atomic number for beryllium is 4 square divided by 2 square, because it is they are given first excited state. They are given first excited state, that is 2 is 2 square, which is equal to 16 by 4, which is 4. Hence the ratio is 1:4. Option A is the correct answer. Question number 82. Which among the following nuclei are fissile? Fissile is nothing but a fissionable. It's nothing but a fissionable or breakable. Here in this option, uranium-238 is a non-fissionable, is a non-fissile. You cannot break this nucleus, and you can break this nucleus 233, you can break this 239 plutonium, uranium-235, these three is fissile, whereas uranium-238 is non-fissile. Hence here option C is the correct answer. Which detector works on the principle of ionization of gases? It is Geiger-Muller counter. Geiger-Muller counter. In this counter, there is a Geiger-Muller counter where the gases they are sent here. Inside the chamber there will be an inert gas like helium, and here you will have the detector. The gas gets ionized. In which alpha rays is ionized easily than beta and gamma rays. Hence Geiger-Muller counter which detects the ionization of gaseous molecule. Option C is the correct answer. Here option B, scintillation counter, is nothing but a photon emission. It's a photon emission, and this detector this option is ruled out. Semiconductor detector was not used here, hence option A is also wrong. Option C is the correct answer. Question number 84. A radioactivity is a random phenomenon. The error in measuring activity in CPM can be reduced by. Here option A is the correct answer. Measuring the activity for a longer period of time. This is the question number 85. A proton is 1836 times heavier than an electron. The ratio of de Broglie wavelength lambda c by lambda p is. Here lambda is given as h by mv. mv is the momentum, h is a Planck's constant, and here this h by v is a constant. Hence lambda is inversely proportional to this mass, which implies lambda for electron, lambda for a proton. If we take here, the mass is inversely proportional due to inverse proportionality, which is equal to a mass of proton divided by mass of electron. This mass of electron is inversely proportional to mass of the lambda is inversely proportional. Lambda p is inversely proportional to mass p. Hence here mp is given, that is 1836 times. Mass of electron is 1. Hence the ratio 1836 is to 1. Option C is the correct answer. A similar question, the question number 86, an electron and a proton are accelerated through the same potential. The ratio of de Broglie wavelength lambda e divided by lambda p is. For it, let us take this de Broglie wavelength, lambda equal to h by root of 2m e. Here h and 2 is a constant and e is also constant, because e means the same potential. They have given a same potential. Hence e is also constant. H by 2 is also constant. Here lambda is inversely proportional to square root of m. And similarly, let us take now wavelength of electron, wavelength of proton, which is equal to wavelength of proton, wavelength of electron, or mp by me 1 by 2. Option A is the correct answer. Thank you for watching. We will meet in the next video, part 7. Thank you.